Okay, take a look at the warm-up. It says to describe the transformation. What kind of equations are these? What type of graphs are these?
Parabolas.
Yes, these are parabolas. So this is kind of a review on transformations. What is this x squared minus 3 telling us to do with the graph? Tommy? Go down 3. All right, what does number 2 tell you to do? Tommy? 4 to the right. Okay, remember whenever it's inside, when it's part of the power, you go the opposite. All right, now, even though this is with quadratics, and we're working on exponentials now, but your transformations are the same, except it's not with an x squared. It's going to be with like a 3 to the x power. So all through all your courses, in fact, this same lesson I taught in my Algebra 2 class at the beginning of the year, because every single course you're going to go over transformations, and they're always going to be the same. You just transform a different parent function. So you have lines, quadratics, which are parabolas, and what we're doing is our exponentials. That's what this course is about. When you get into Algebra 2, you'll add different types of graphs. I do have your quizzes graded, by the way. A couple people still need to take it. Who was not? I know Auburn wasn't here. Did somebody else not take it yesterday? Okay, so I need to get with you guys about making that up, and then y'all will get yours back. If it's already on Infinite Campus, you've probably already seen it on there. Graphing and characteristics of exponentials is what we're doing today. All right, so let me see your note guide. I guess you need to write this down somewhere. Maybe up near the title. This is just your standard form. A times b to the x minus h plus x plus k. So we're going to go through and tell what each of these variables represents. Are you ready? There you go. You're welcome. K moves it up or down. In the warm-up, I think it was a minus 3, wasn't it x squared minus 3? That negative 3 moved it down. So K will move it down if it's positive, up if it's negative. Wait. Up if it's positive, down if it's negative, yeah. H moves it right or left. And that's the opposite of what you think because it says x minus h. So if it's x minus 4, it's going to go which way?
To the right.
To the right. And if it's x plus 1, it would move to the left. That was a little confusing for y'all with parabolas. If A is negative, a negative A reflects the graph across the x-axis. I'm going back up. There you go. A little bit of bass, huh? Okay, so let's just name H and K and then describe the transformation. 2 is K. Does it fly in? Yeah. And what does it tell us to do? Go up 2. Okay, what about the next one? Do I have an H or a K? A K. And you're going to down 5, right?
So you can have H4.
No, you can have both. All you're doing is picking out K or H. H is with the exponent. K is not.
25 thirds plus 1. Would that be the entire thing move? Or never mind, that was...
Okay, now is this H or K?
H.
H. When you pull it out, what is H? Okay, it means you're going to go to the left one, yes. You got it? It depends on how you look at it. We went through this with quadratics also. If you look at it just like this, yes. But if you pull it out, h is -1. Okay, and then that's going to be left. See, here it said to name h and k, but we didn't actually name h and k. We just named the transformation. All right, any questions? Auburn, you good? And Amber? All right. All right, now, correct. That's going to go to the right 3. And your middle one? Reflect over the x-axis. That's right, because A is negative. And what about the last one? No, it doesn't. No. You're thinking of exponents. When you have negative exponents, that's when you can move it up and down. This is not on the exponent. The negative's on the 2. All right, now we're going to get to graphing them in just a minute. All right, look at domain and range now. Whoa, back it up. All right, for exponentials, when you'll see this in a minute when I show you the graph, but your domain and range is all real numbers. Just like what? What else had a domain and range of all real numbers? Yes, the parabolas, or your quadratics, yes. The range, you're going to use k. So it's going to be k, it's either going to be everything above k or everything under k. If a is positive, it's going to be k to infinity. And this is very easy to see in a graph. And if a is negative, it's going to be negative infinity to k. So don't worry about memorizing this. When you see in the graph, it'll be obvious. Just like with the parabolas.
A is positive, it's going to be k to infinity.
Right. Ready? Identify the domain, domain and range. All right, what do we know about the domain for all of them? All real numbers. What is the range on the first one? What's k?
4.
K is 4. Let me go back. Okay, so if A is positive, you just look at A. A was positive in that one, wasn't it?
No,
It's negative. All right, K, A was negative, so you're going to use negative infinity to K. Yes. So there's your Yeah, you actually put the value of K in there. All right, what about the next one? What is K? 0, that's right. So and A is positive or negative? Yes. Very good. Okay, and the last one. Good. Nah. All right, any questions? All right, so what we've done is we've picked out H and K. We've looked at right, left, up, or down. We also have looked at what it reflects around the x-axis, domain, and range. But still, you don't know what the graph looks like, do you? Or do you? Does anyone know what an exponential graph looks like? It's not a line. It's not a line. It's a curve. And we're going to get to those. All right, asymptotes. This is, we've kind of talked about it a little bit on some graphs, but this is the first time you really actually dealt with an asymptote. Because lines do not have asymptotes, neither do parabolas. It's a line that a graph approaches but will never touch. It's horizontal and it's a dashed line. Let me put in a disclaimer here. This is true for exponentials. Later on in Algebra 2 and in pre-calculus, your world's going to be crushed when your teacher says, oh, but you can touch a horizontal asymptote. There are some graphs that will touch a horizontal asymptote and even cross it. Not in here, not in this class, not in exponentials. But I want you to know that that's going to happen later. It doesn't happen a lot, but it does happen. All right, so now this is your horizontal asymptote, y equals k. Now, always y equals k. Not just k, y equals k. All right, so now we're going to identify the asymptote for each of these graphs. Can you identify k? I mean, I'm just asking y'all a question. Can you identify k? Then you can identify the asymptote. So it's y equals whatever k is. Y equals 4. All right, since we're at, let's go ahead and talk a little bit more on number 13. What is the transformations on number 13? Up 4? Right 2. Okay. All right, tell me the transformations on this one before we name the asymptote.
Down 3.
Down 3 and what 2? Left 2. And what's the asymptote? Y equals -3. Yeah, you got to have that y equals. Because it's a line. It is a line, and lines have to have an equation. Okay, the next one. Oh, yes, y equals 0. That's right. And y equals 0 is the x-axis. But what does this right here do, that negative? Flips it, yes. Okay, nice. I have no idea why all the other ones were not numbered, and all of a sudden we got 13, 14, 15. Are they numbered on your paper? No. All right, I need to fix that. Okay, an x-intercept. I don't care if you are graphing rational expressions, which you don't do until later, rational equations, if you're going to graph a line, if you're graphing parabolas, if you're graphing exponentials, I don't care what you're graphing. When you find the x-intercept, it's always some number, comma, 0. To find an x-intercept, you always let y equal 0. To find a y-intercept, you always let x equal 0. I don't care what kind of graph it is. This is always true. Now, I've shown you this before, but I mean, if you have a graph, ooh, that's pretty ugly. Okay? And let's say this is by ones. What's that ordered pair? 2, 0. What's that ordered pair? What do those two have in common? The y coordinate is 0. This is your y-axis, this is your x-axis. Both of those have a y coordinate of 0. Y coordinate is always 0 on an x-intercept. These are crossing the x-axis, the y coordinate is always 0. Zero, 1. And do you see what they have in common? The x is always 0. So for the x-intercept, your y is always 0. For your y-intercept, your x is always 0. And that's why. Okay, when you read a graph, you read it from left to right. If it's going up, it's increasing. Down, it's decreasing. We've gone through this before with parabolas, remember? Your rules are basically the same. Well, they are for this. Ready? I'll show you increase and decrease when we get to the graphs. End behaviors. Your end behaviors are what's going on the ends of the graph. In a parabola, on the ends, if your parabola, it looks like this, your parabola is going to positive infinity on the ends. What if it looks like this? Negative infinity. So always it starts with as x approaches, if I want to go to the right, x approaches infinity, and when I go to the left, negative infinity. This is going to change. I'm not going to fill anything in there because I don't know until I look at the graph. But this will always be the same. This means as x goes to the right, what is the y doing? It's either going up or down. If x goes to the left, what is y doing? Is it going up or down? And sometimes it can go towards the asymptote. So this right here, I'm not filling that in yet because that depends on the graph. But this will always be. I don't care what kind of graph you're looking at, your end behaviors always start with x equals, or x approaches infinity and x approaches negative infinity. They might be swapped in a different order, that doesn't matter, but that's always going to be true. Okay, now we're going to do one. I got to pull it up. Let me pull it up. Okay, are you ready? Don't forget that anytime you're graphing, what's something you can always do? Plot points. You can always make an x and y chart. And that will, I don't care what kind of graph it is, if you know the shape of the graph, you just get some points. All right, so first of all, let's talk about the transformations. So look at the equation.
Across the
Yes. Reflex. Two C's? No. There you go. Okay. Reflects across the x-axis. Now it says to state 3 points. Well, let's find 3 points. Okay. How about we put in a -1, a 0, and a 1. If you have -1, it means -5 to the -1. Simplify that. How do I simplify that? You don't understand? I'm just putting a -1 in for x. Because I have to graph this. When you're graphing numbers, always put in some positives, some negatives, and 0. So I just chose -1, 0, and 1. You can choose. No. I've got right here. I put in -1, and I get out -5 to the -1 power. Are you with me on that? Yes, it's going in for x. Now, when you have a negative exponent, what does it mean to do? Move me. Oh, so when the base is -5, where are you going to put the -5? In the denominator. And now it's a positive 1. That was we did that last week. So that gives me the order pair -1, -1/5. What? That's a 5.
It kind of looks like a 3.
It's a 5. All right, now when I put in a 0, be careful here. -5 to the 0 power. What's being raised to the 0 power?
It'd be 0.
Yes, it's -1. All right, but 5 is what I want you to see is the negative is not being raised to 0 power. That's only true if there's parentheses around it. Just the 5 is. So that's going to be -1. And now 1. -5 to the first power is -5. All right, there's 3 points. Your 3 points might not match my 3 points. I mean, I'm sure they do on this one, yes. I always put in -1, 0, and 5, and if it gets too messy, I might put in something else. All right, so now I'm going to plot those points. -1, -1/5. All right, that's just really close to the x-axis. 0, -1. 1, -5. Now this is a curve. It's some type of a curve whenever we graph it. I'm not connecting them yet.
Wait, would you use that?
No, you don't use axis of symmetry for this one. All right, so I'll connect it in just a minute. I'm going to do some more things first. I'll come back to domain and range. What about an asymptote? The asymptote is y equals k, Tommy? Yes, it would be y equals 0 because nothing's being added or subtracted to that base. Here's how you draw an asymptote. Y equals 0, it's a horizontal line, dotted or dashed, whatever you want to call it, at that point, 0, or at that y equals 0. Now that means that this curve gets very, very close to that asymptote, but it's not going to go across it, it's not going to touch it, so it's going to look like this. And it gets closer, it looks like it touches it, but it doesn't, because I can't show you how close it can get. And this will continue going that way. Now let me talk about why it doesn't touch it. For it to touch it, this right here would have to actually become 0. There is not a power that I can raise -5 to get 0. So what it does is when I put in -2, -3, -4, it just gets closer and closer. It gets very, very, very close to that, very small numbers. That's what it looks like without that little bump right there. It's supposed to be a smooth curve. All right, now let's identify the domain and range. What's your domain? All right, now the range. Are we looking at the values above or below your asymptote? Below. All right, so it's from the asymptote down. You got that? All right, so how do I say that in interval notation? From the asymptote down. All right, let's look at, I'm going to write exactly what you said, and we're going to see if it's right. All right, in that interval notation, is the smaller number on the left? Yes, -infinity is smaller than 0. All right, and that means it's starting at -infinity and going up to 0, so that is correct. Always look back and make sure that the smaller number is on the left.
Domain always going to be negative.
Yes, it will. Another way that you could say the range is you could say that it's the y values that are less than or equal to 0. I want you to be familiar with both because I don't know how the milestone is going to state it. All right, is this, now when you read it, don't follow the arrows. You read it from left to right. What is this doing? Is it going up or down? So it's decreasing. Where does it cross the x-axis? It doesn't. Remember, it gets closer and closer to the asymptote. So there is no x-axis, x-intercept. Put none. Yeah, 0, 0 is a point. Now, does it have a y-intercept? Yes. All right, now in behaviors. All right, I'm going to start with as it goes to the right because it's positive infinity. So as I move to the right, is it going up or down? It's going down, so that means -infinity. Now when I go to the left, what is it getting closer and closer and closer to? Yes? Asymptote. And what is the asymptote? 0. We are. All right, so that is, right there is everything you need to know about exponential characteristics. All right, let's do another one together, and then I'm going to let you do the next one. Okay, in behaviors mean, right, this is right, this is right and this is left. Yes, going to the right and going to the left. As I move to the right, this graph is going down continuously. All right, now if I look at the left, now you're looking at what is the y doing, okay? So my answer is it going up or down? Well, it's not going up, 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 up. I mean, but what is it going to reach? Is it going to reach infinity? No, it doesn't go any further than 0. But it's not going to go above 0. You're not looking at it right and left. We're looking at up and down. This is right and left. This part's up and down. And if you'll recall that slide earlier, it said that this is your range. Your asymptote is going to be one of these in behaviors. All right, let's look at another one now. We have 1/2 x plus 3. All right, what's going to happen to this graph? What's the transformation? It's going to go up 3. Let me talk about this one we just did. This will reflect across the x-axis. That means that if I flipped it, the graph looked like this. See that? That's what your parent function looks like. Your exponential. Don't do this. Don't copy this down. But I'm just kind of reflecting it. That would be your regular exponential function right there, and we flipped it. Okay, so we're going to take your regular exponential function, this time, and move it up 3. All right, that's just a rough sketch there. Sounds like a dog. Rough sketch. Okay, so we need to state 3 points. And I'm going to choose the same 3 points I always choose, -1, 0, and 1. If they turn out to be too messy, I'll pick another. All right, so I have, You know, this might be easier instead of making a chart to do it like this. F of -1, and I'll fill it into the chart in a minute. So I have 1/2 to the -1 power plus 3. So I substituted -1 for the x. Now what does a -1 power tell us to do? You're gonna move it. You're gonna flip it. All right. When you have a fraction raised to the -1 power, you're just gonna take the reciprocal of that fraction. Here's why. If you can remember this, it'll save you some time. 1/2 to the -1 means 1 to the -1 and 2 to the -1. You remember when you have a quotient, they both get that exponent. And the negative exponents mean to do what with the base? Move it. So the 1 goes to the bottom, now it's a +1. The 2 goes to the top, now it's a +1. So all it does is flip it.
So for the x, how
Always use some positives, some negatives, and 0. All right, so that's going to be 2 plus 3, which is 5. Now we're going to put in a 0. I have 1/2 to the 0 plus 3. What will that simplify to? 4. 1 plus 3. And now to the first power. 1/2 to the first power plus 3 is 3.5. So the 3 points that I have are -1, 5, 0, 4, and 1, 3.5. Okay, plot those 3 points. -1, 5, 0, 4, 1, 3.5.
can we use that way instead of the other way? Like the way we used originally?
What?
Like with the one that we used on the first problem. We used it a different way than we did that one.
What do you mean?
Like the x instead of x.
It's the same thing. I just didn't have to write it out.
Okay.
I put it out beside it, you see? And since it was more than just one step, I wrote out the steps. All right, now, if you're not sure what the graph's doing, you can always get more points. Let me just show you this. You don't have to get more points, but until you get the feel of what the graph does. If I put in another number, f of 2, I'm going to have 1/2 to the second power plus 3. What's that going to be? 3 1/4. 1/2 to the second power is 1/4 plus 3. If I put in a 3, I'm going to have 1/8, 3 1/8. You see what's happening here? It is decreasing, but is it ever going to get to just 3? No, because for it to get to 3, this right here would have to be 0, and that's never going to be 0. So what do you think, what does that make 3? The asymptote, which is y equals k. So your asymptote is right here. And now you can see that it's not going to get to the asymptote. So when I graph this, it's just going to get closer and closer and closer. It looks like that.
So none of them ever touch the x.
Not exponentials. These, right. Later, you may see that way later on, but you won't see that in here.
Wait, but is it increasing?
Is it increasing or decreasing? Yeah, you read it from left to right. So it is decreasing. What's your domain? All right, now the range. Is it above or below the asymptote? Above. All right, so that means it's going to go to what? Infinity. And that's going to be on the right because you can't get bigger than infinity. What's going to go on the left? How far down does it go? 3. So from 3 to infinity. Or you could say y's are greater than or not. Oh, did I put or equal to 0 on that last one? Oh, it should have just been greater than. Y is greater than 3. Yeah, back up here. Yeah, that should have just been greater than because it doesn't get to 0. Or less than it. Yes, change that.
You did the less than for
Right.
For the home. You did the less than symbol instead of the greater than.
It's supposed to be less than. It's all the less than 0.
Oh.
Okay, now the x-intercept. Where does this graph cross the x-axis? It doesn't. Is there a y-intercept?
Here, 4.
All right, now for the end behaviors. Okay, so when it goes to infinity, it's going to go to 3, good. And then at negative infinity, it goes up, so very good.